Good morning, everybody. My name is Gill. I am an SE in the Checkpoint UK office, and I specifically work in the channel team. Today, I am delighted and thrilled to host this Friday's webinar, Virtual Security, better known as vSEC. Last week, I hosted a webinar securing the securing the software-defined data center. We're going to take a few moments to recap on some of the more salient points that I covered, as naturally this will lead to our main topic of today, vSEC. In my presentation last week, we started off in what is the software-defined data center. There are many components that come about to bring the software-defined data center. However, there are three main pinnacle components. The first is a hypervisor. This is the virtual compute, better known as your virtual machines or virtual servers. Then you have an SDN controller. SDN is short for software-defined networking. The role of the SDN controller, primarily, is the virtualization of networks, which provides us a leap of functionalities when looking at the software-defined data center. The third main component within a software-defined data center is the management or automated software piece. This is the component that allows administrators a single place to orchestrate and automate all of their applications. We then went on within the presentation to discuss some of the security challenges that comes about with a software-defined data center. The first of which is the increase of traffic inside the data center. This is obvious because within our software-defined data center, within our physical host, we have a number of virtual machines, virtual servers within the data center. There are a lot of inter and intra-communication between virtual machines and other virtual machines. In fact, the amount of traffic within our software-defined data center is considered to be 80%. We consider this traffic to be east to westbound traffic or lateral traffic. Currently, this traffic doesn't traverse our perimeter gateway, so we are blind to this traffic. We have no idea what this traffic is. This follows on to our second point, the lateral threats. Because we lack that visibility within that key 80% of traffic, malware can move from applications to applications from the east to west or lateral direction without much contention. The third challenge that comes about with a software-defined data center is dynamic changes. If you recall in our presentation, we discussed the server team's day-to-day operations. This could be from building a new virtual machine, to removing existing virtual machines, to pulling out a virtual machine from an existing farm, to introducing a new virtual machine into a farm, to changing the IP address of a virtual machine, to reverting a virtual machine to a previous IP address, and so on. There are many changes that are happening in the software-defined data center, and one of the main challenges is security keeping up with those dynamic changes. That's because we rely on traditional static security control, which impedes the business agility to deliver. In fact, if a new virtual machine was provisioned and I profiled this to be a new web server with its own IP address, I then have to raise a ticket with the security team in order to request them to create the necessary security profile for this new virtual machine. If you multiply that by the number of changes that's happening in a software-defined data center on a day-to-day basis, you can start to see how this becomes a bone of contention. The fourth challenge presented in the software-defined data center is the diverse cloud environments we enable within these data centers. Most software-defined data centers have connections into infrastructure as a service platforms. This could be Amazon Web Services, Azure, vCloud, and so on. So not only do we have our private cloud, a public cloud, but also a hybrid cloud. And this again poses considerable challenges within the software-defined data center from a security perspective. So at this point, we understand what a software-defined data center is and some of the challenges that come about. So within the presentation that I delivered last week, we discussed what three key things we needed to do in order to address these challenges. The first, being the obvious, is security visibility into the traffic that's inside the data center. We need to know what that 80% of traffic is. We need to know what the communication is coming from a virtual machine to another virtual machine and vice versa. The second key requirement is automated security provisioning to keep pace with dynamic data center changes. So this follows on from our previous example, where we discussed the day-to-day operations of a server team. We need to be able to detect and identify a new virtual machine that's provisioned to be a web server, for example, and therefore an existing security profile already exists for that web server farm, and we need to automatically provision the security profile for this new virtual machine. And if that virtual machine is then taken down for maintenance, we need to also adapt the security profile for that change. And this needs to be done in an automated fashion. In fact, it needs to be done in real time as and when the server team make these changes, not waiting on the security team to make these changes in a manual human intervention manner. The third key point in addressing these challenges naturally follows on from the first point: automated insertion and deployment of advanced threat prevention to protect inside the data center. So now that we have that security visibility, we can see that 80% traffic within our software-defined data center. It's now time to leverage advanced threat prevention functions such as IPS, anti-bot, antivirus within the data center. So protecting virtual machines from other virtual machines is the most simplistic example of this. Finally, we concluded the presentation from last week with vSEC, Checkpoint's very own solution in manifesting those security requirements we discussed and addressing the key challenges we identified within a software-defined data center. We discussed the three main components that vSEC brings to the table. First, data center segmentation. vSEC is able to take a flat network of virtual machines, so imagine a physical EXI host or cluster with hundreds, if not thousands of virtual machines. With our integration with these controllers, we can provide microsegmentations based on the role that these virtual machines provide, or any other number of metrics that we decide to implement. With this segmentation, we can then leverage advanced threat prevention, e.g. IPS, anti-bot, antivirus, and so forth within this traffic. The second main component that vSEC brings to the table is automation of virtual network and security. So if a virtual machine is taken into maintenance, we can automatically provision a security profile without any real human intervention, and thereby producing an environment that satisfies both the security teams and the server teams on their day-to-day operations. Should the virtual machine then become a member of a predefined profile, a predefined group, again that security profile will be orchestrated to match those requirements. And then we can dictate what these virtual machines or groups of virtual machines can and can't do across other virtual machines and group of virtual machines. The third main component is security and control for all data center traffic, and this is key. We can now provide a consistent security policy, a unified security policy across our east and west traffic. Remember, this is the 80% traffic that we're currently blind to because it doesn't traverse our perimeter gateway, as well as the north and southbound traffic. This is the traffic that we do see on the perimeter gateway that's coming into our data center and coming out of our data center. Now we have the ability to provide a unified policy. We don't require or rely on multiple disparate point products or different management systems in order to make this happen. And we'll see in this presentation how that's achieved. Okay, so this brings us on to the main topic of today's discussion, vSEC. So let's talk about it. vSEC has two components. You have the vSEC gateway. This effectively lives within the hypervisor of our software-defined data center and secures the traffic between different applications, i.e. between virtual machines and other virtual machines or groups of virtual machines. We then have the vSEC controller. This lives within our smart manager, our smart center, it's installed as an add-on. And the role of the vSEC controller is to integrate with the SDN controllers within our software-defined data center, the cloud management platforms as well, and within that integration provide a unified management policy with automated security. Again, we will dive into a bit more details as to what this effectively means. Let's start with the vSEC gateway. As we've already pointed out, the vSEC gateway integrates with the SDN controller to provide microsegmentation and advanced security. Currently today, vSEC supports VMware's NSX SDN controller. However, there are more SDN controllers in existence today, and we will cover towards the end of the presentation which other controllers are currently on the roadmap and will be supported shortly. With that in mind, our main example will focus on VMware's NSX, as that will be the most relatable example when we discuss SDN controllers for the purpose of this presentation. As previously mentioned, the vSEC gateway sits within the hypervisor, and as such is then able to leverage the software blades we currently utilize today in our physical gateways. This can be from firewall or the IPS software blade, which allows organizations to stop exploits of known vulnerabilities until those servers or systems can be patched and remediated. Antivirus, which helps organizations protect their users from inadvertently downloading malicious files whilst web browsing or receiving them through the email channel. Antibot, which effectively allows an organization to prevent bot damage from infected devices. As we know, bots tend to be missed by antivirus products. This is because bots by nature is very lightweight. It almost looks like a legitimate traffic profile. And once installed, it effectively does nothing until it connects to its command and control server, which is the bad guys on the internet, and at that point says, hey, I've now installed, what would you like me to do? And at that point in time, the command controller can then execute payload or instructions so that that particular bot, that particular infected machine, can either go on to be a DDoS bot, can be a banking bot, can even be instructed to proliferate the network, look for key files and perform data exfiltration, and so on. So the key here is, yes, bots are hard to detect, but what we can do is prevent the bot from connecting to a command and control server, thereby rendering it useless, and then alert the admin team about the infected machine. We also have the Sandblast. Sandblast is pretty cool and funky. It allows us to respond to zero-day or unknown malware. This is malware that currently cannot be identified by our existing IPS antivirus or antibot solutions that rely on known profiles, i.e. a known signature, a known MD5 hash. There's always a patient zero. So with Sandblast, we can effectively emulate the file in a virtual environment. We call this a virtual sandboxing technology. And by emulating the file, we can then observe the file's behavior. If the file is a PDF and tries to nuke the hard drive, well, that's okay because it's a virtual environment. Whatever happens in that virtual environment stays in that virtual environment. However, we can now, based on the behavior, classify this malware as either being benign or malicious, which gives us good intel, and thereby within that intel, we can stop a malicious malware, an unknown or zero-day attack from entering our production network. We also have application control and URL filtering. This allows us to define granular policies, and we can do some really cool things, such as define a policy that says only the HR department within my Active Directory can access Facebook, but they can't access Facebook chat, Facebook Bejeweled, Facebook posting, and effectively we make Facebook a read-only purpose to support the business needs. Likewise, we can differentiate between a Skype video call versus a Skype file transfer, and so on. Okay, so up to this point, we now know what a software-defined data center is. We know the challenges. We know what the key requirements are to address those challenges. We know that vSEC from Checkpoint is the main component that allows us to address the challenges we discussed. We've also identified the two main components of vSEC, which is the controller and the gateway. we talked about what the gateway does. It sits in the hypervisor and leverages the advanced software blades for both microsegmentation and advanced security. So let's discuss how we now implement vSEC in terms of its controller and gateway within our software-defined data center. The first step is to integrate the vSEC controller with the SDN and cloud controllers. As mentioned previously, we're going to use VMware's NSX as an example of our SDN controller. Once we have that integration, effectively Checkpoint Manager and the SDN Controller Manager become best friends. In fact, everything the VMware NSX Manager knows will report to Checkpoint and vice versa. This means with the integration, we can do some automated tasks already, such as if our server team provisions new ESXi hosts, so imagine there's a cluster of 10 physical hosts in the ESXi cluster, and the server team provision 4 more. Well, the VMware NSX Manager knows that it needs to install a vSEC gateway automatically on those new ESXi servers. It then notifies Checkpoint to say, hey, we provision new ESXi hosts, and they now have your vSEC gateway installed within the hypervisor. The Checkpoint Manager says, okay, roger that, thank you very much, and then ensures that it has an up-to-date policy as defined by the administrator and also up-to-date malwares and signatures, and all of this happens without any real human intervention at all. Hence, the operative word here, automatic, or automation. Let's look at that from a different angle. So here we have our shared context policy and auto updates. If we look at the checkpoint policy here, we have rule 3, which effectively stipulates that any traffic going to a group called database, and the point to note here that this is a security group within NSX. Checkpoint management imports the objects from NSX and vCenter into the policy. So whenever there are objects that are added, removed, or changed within the NSX environment, Checkpoint will know about this automatically, dynamically, and in real time. In Rule 3.1, we're leveraging an object within vCenter called Web VM1, and traffic to the database virtual machine, again another vCenter object, is dictated by policy to be allowed for SQL traffic. So again, we can now provide and provision fine-grained security policies tied to the NSX security groups directly and the virtual machine identities to bring about an automatic update within the policy. The second step is to secure the north and southbound traffic, because again, that's still important. Although the east and west or the lateral traffic makes up 80%, we need to have a complete picture. And we can secure the north and southbound traffic with a software-defined data center aware perimeter appliance. For those of you familiar with Checkpoint, and as majority of you are partners, you'll be aware that we have gateways to meet the needs and sizes of many organizations, from a small 600 appliance all the way up to a big mammoth of appliance, 61,000, or rather a chassis. Once we've integrated the perimeter gateway, we deploy the vSEC gateway inside the private cloud fabrics, i.e. it's installed within the hypervisor of a software-defined data center, and then we define the policy. Once this is done, we can then effectively steer that east to west traffic, that 80% traffic we're blind to, through the Checkpoint vSEC in order to enforce policy and gain visibility as dictated by the policy that the admins have set up. So let's see that in a little bit more detail. So if we go into our favorite SDN, or rather the example of our SDN controller, in this case VMware's NSX, they have something called Service Composer. Within the Service Composer, you effectively define what traffic from our virtual machines goes through the Checkpoint vSEC gateway. In this example, we are transparently forwarding from the NSX perspective any traffic from a security group called Web Service SG, and within NSX you can define security groups. As you build your virtual machines, you can tag them to belong into a group. So if you build a new virtual machine that's going to be a web server, and it's going to be part of an existing farm, you simply tag it as, I don't know, web server, and that automatically inserts it into the web server SG group. So NSX transparently forwards the traffic to the checkpoint virtual gateway. Once we're at this stage, we now have the foundation set about in order to produce the final step, step 5, which is orchestrate. We can now securely orchestrate and automate the operations we have discussed previously within this presentation, as well as my last week's presentation. In fact, let's see that in a bit more details. So here we have the checkpoint policy. We're leveraging those NSX security groups automatically due to the integration we have and the real-time updates we receive. Here in this particular policy, we have finance users. So this is taken directly from identity awareness, which gives us the mechanism to take objects directly from our Active Directory server into our checkpoint policy. So within Active Directory, we have a group called finance users, and therefore we are leveraging those same users. So from finance users going to our NSX security group, web servers SG, anything that's HTTPS, we're going to inspect it for IPS and antibot, and this will be enforced by the perimeter gateway. And that's because obviously this is traffic that's coming out of the data center, or rather coming from the outside world into the data center. And therefore the enforcement point, the obvious choice, is the physical gateway within our software-defined data center. In our second example, in our second rule, we have the web server NSX security group, traffic from there going to the app servers NSX security group. So if you follow my mouse, which I'll bring here, so that's traffic from here going to here. Notice that this traffic doesn't traverse the physical gateway, which is here. So in this particular policy, and again this is a unified policy, we're stipulating that the web server traffic going to the app server traffic using a service RabbitMQ, we want to inspect that with firewall and IPS. And obviously the enforcement point at this conjuncture will be the vSEC gateway. You can now start to see how we leverage our perimeter gateway and our vSEC gateway to provide a unified policy which not only gives us visibility but absolute control within our software-defined data center. And in the third final rule, we're stipulating that anything within the NSX security group called web servers SG, that's not RabbitMQ and it's not going to the app servers, we're going to block that, and again the enforcement point will be the vSEC gateway. So hopefully you can start to see and build a picture in your mind's eye of how this all sort of commingles together to provide this really robust control. Again, I like to approach things by multiple angles, so we're going to go through another example which effectively builds upon our previous example, just so that we build that picture in our mental vision, in our mind's eye. So in the shared context policy and auto updates, here we have a web server, we have a database server, and we have a virtual machine. We have our vSEC controller, which is integrating with the NSX manager, and of course the vCenter. So in this example, the web server is speaking to the database server. But if you notice just there, momentarily, the virtual machine, the gray virtual machine on the left, couldn't talk to the database server. This is because the policy that we've set about only allows web server databases, only allows web servers to talk to the database servers. In fact, if we look at the policy, we can see, and I appreciate it's slightly small, but we can see that there is a group called web VMs, which is directly imported from the NSX security group. And that group can specifically talk to a virtual machine, which is pulled by the vCenter object called database over SQL, and that's the only permitted traffic. Now, because our virtual machine on the left, the gray one, is not part of the web VM NSX security group, it doesn't comply with the policy, and therefore its traffic is stopped in the path. However, that virtual machine is now a web server. The server team has now provisioned that virtual machine to become part of the web server farm. Maybe this is web server 04 and is introduced into the web server farm. So the machine joins a security group that's already defined in policy. So now it can talk to the database server because the security gateway enforces the policy dynamically. We do not need to push a policy install or require any real human intervention to make this happen. This is the main theme of what we bring with vSEC, the automation and orchestration piece. Another neat feature we can do with this automation and orchestration feature is the automatic tagging of infected machines. So if a virtual machine is infected by a bot, as an example, we can tag that virtual machine and provide that tag to the NSX manager. And this is particularly useful, and this is quite unique to Checkpoint's offering in the fact that we can provide these tags. So within the VMware's NSX management environment, it could be set up to alert relevant admin teams, or it could have automatic rules that handle infected machines, such as moving the virtual machine out into a quarantine group, scrubbing it, retesting it, and if it passes those tests, that virtual machine is then removed from the quarantine group back to its original group that it came from. And all of this happens in an automated fashion without human intervention and in real time. And again, I like to approach things in multiple angles, so we're going to look at this from a different perspective just to help build that picture in our mind's eye. So when we look at threat prevention tagging, we can notice that this virtual machine here has become compromised. It tries to initiate a command and control connection. However, because we are running anti-bot within our gateway, we can intercept that connection and block that connection from occurring, thereby rendering that bot useless. It's how this automation orchestration really compels and propels rather our software-defined data center, and how the orchestration automation really helps achieve the security challenges we discussed earlier on and how we are addressing them. So hopefully up to this point, you are now familiar with A, what a software-defined data center is, the challenges, or the security challenges rather, that come about with a software-defined data center, the main requirements we need to address those challenges, vSEC being a manifestation of those security requirements, which is offered by Checkpoint, what vSEC is in terms of its two main components, the controller, the gateway, and how we go about integrating the two within our software-defined data center to provide automation and orchestration and effectively addressing the four main challenges we discussed earlier on. So at this stage, I'm going to summarize just very quickly. This will be information you already know, but we're going to summarize the general functions of the vSEC gateway and the general functions of the vSEC controller. The general functions of vSEC gateway, as you're undoubtedly aware by now, is context-aware inspection. So it's able to understand the traffic it is seeing. With that in mind, the vSEC gateway provides microsegmentation. This is seen in the examples of where we leverage the SDN controller groups. In the examples previously, this was VMware's NSX security groups directly into the policy, and any changes that had occurred to those groups within the NSX ecosystem will be updated automatically within Checkpoint without any human intervention in real time. And then with this, the vSEC gateway then leverages advanced threat prevention in the form of software blades. And of course, it provides network agnostic inspection and service insertion. As we've seen in the previous examples, one of these service insertions is the automatic tagging of infected machines. The vSEC controller's general functions is to integrate with the SDN controller. Notice here, we are mentioning Cisco ACI, OpenStack, Azure, and Amazon Web Services. We'll discuss this towards the end of the presentation, but for now, the focus is within the context of a software-defined data center, and therefore, in our example, integrates with VMware's NSX, which is their implementation of an SDN controller. With this integration, we can use the cloud management objects within the Checkpoint security policy, as we've seen in our previous examples. It then automatically updates changes to the objects in the policy, gateways, and logs in real time. So anytime there's effectively a change within the NSX ecosystem, within the day-to-day operations of our server teams, we will automatically be updated, and therefore the security profile adapts automatically to these changes. So if the virtual machine is now no longer in a farm, or if it's been inserted in a farm, again, the security profiles are already provisioned to make that happen. And if an IP address changes in one of the objects, we will know about that automatically. So when you look at the security logs within Checkpoint, you'll see the IP address and the name of the virtual machine that's consistent to what it is at that point in time in the NSX ecosystem. Another main function of the vSEC controller is to notify the SDN controllers to mitigate or quarantine infected applications. So that's our example previously where we can tag, where we can detect a virtual machine has been infected, and we can tag that information to the SDN controller so that they can leverage their own policy around what to do with it. It also allows the SDN controller to provision vSEC gateways when needed. So again, if the server team provision a couple of new ESXi hosts, well, because of this integration, the SDN controller can now provision the vSEC gateway and notify the checkpoint manager or the vSEC controller about this. And of course, in the many examples we've enumerated in this presentation, its main focus is to orchestrate the new application with security policy template. Okay, so hopefully at this stage we have a very good idea now of what vSEC is and how it sort of plays a critical part in our software-defined data center. So let's talk about licensing. So if we hover over to our favorite product catalog, we go into the vSEC section and we select vSEC for private cloud with SDN. You can see at the moment we have vSEC gateway for VMware NSX highlighted. Straight away, from the information presented, we can see the software specifications. We can see that vSEC gateway integrates with VMware's NSX 5.5 and above. We can also see that the vSEC controller integrates with the NSX and vCenter platforms. And it also provides unified management for both virtual and physical gateways, all of which we know through the presentation that we've just seen. Now the SKU that's available today is CPSG-VSEC-NSX-NGTP-GW, or gateway. And that is composed by the following software blades: firewall, VPN, identity awareness, IPS app control, URL filtering, antivirus, antibot, and anti-spam. So at this stage, we know where to get the license. We know what SKU we need. But how do we know how many? What is the quantity? How do we know how many of these SKUs we need from a licensing perspective when we look to implement this? So product catalog being our friend, you'll notice within the product catalog there's a link to licensing instructions, which then opens this window. And this is gold dust for any partners leveraging the product catalog. But to summarize, in terms of how we licensing the NSX, the vSECs for NSX, we actually copy, or we actually use the same licensing model that VMware leverages for NSX. So if a customer wants to approach VMware to buy NSX for their SDN controller needs, they are licensed based on the number of physical CPU sockets within the EXI cluster. And we do exactly the same. So if that same said customer now wants to leverage vSEC for SDN controllers to protect their software-defined data center, we do it in the exact same way, where they buy the number of licenses that match the number of physical CPU sockets within the cluster. So as an example, let's imagine we have an ESX cluster of 10 physical hosts. Each of these hosts has 2 physical CPU sockets. Therefore, within the cluster, we have 20 physical CPU sockets. So when we look at the SKU that we mentioned previously, we just multiply that by 20. And from a licensing perspective, that is sufficient for our needs. And really, it's as simple as that. The other main point is, let's say we've bought our licensing. Let's say that the EXI cluster in a 6 months' time is provisioned to have 4 new hosts, each with 2 physical CPU sockets. So therefore, we simply just purchase 8 additional licenses and we assign them to the same vSEC cluster object. The third point to note from a licensing perspective is the management container. Each ESX cluster is considered as a gateway count within the manager. So you could have one EXI cluster with 100 physical hosts, but from the checkpoint management perspective, this is counted as one gateway. You could have 2 EXI clusters, one cluster having 100 hosts, another cluster having 10 hosts, this is considered to be a sum of 2 gateways when we look at the management container. So to put that as an example, if we already have a management container of 10 and it's currently managing 5 physical gateways, and then we want to introduce one EXI cluster which has 1,000 physical hosts, work with me here. Well, from a management perspective, this ESX cluster will be considered as one gateway. So out of the 5 out of the 10 that's currently being used, this will mean we'll be utilizing 6 out of the 10, and therefore we are covered by the existing management container. So the 3 main points to consider when licensing for SDN controllers, in this example VMware's NSX, is that the licensing is based on the number of physical CPU sockets across the EXI cluster. 2, we can provision more licenses as and when we need it, and we assign them to the same vSEC cluster object. And 3, the management container will count each EXI cluster as one gateway. So I kind of alluded earlier on to some more functions that the vSEC provides. In fact, up to this point, we've been discussing vSEC in the context of the software-defined data center. But in fact, that is just one part of vSEC. vSEC in itself is a family of products and solutions. So let's discuss some of the products and solutions within the vSEC family. We're going to step away from our context of software-defined data center and look at the wider picture. So first of all, we have our private cloud. We have our software-defined data center that's secured by vSEC. But we may be connecting to public infrastructure as a service platforms such as AWS, Azure, and vCloud Air. In those instances, we can also secure those public infrastructure as a service platforms with the vSEC family. So what we now provide is a unified security and control for your data center and public infrastructure as a service platform. So the main difference to note here is licensing for these environments. So the licensing for AWS, Azure, or vCloud Air is somewhat different to the licensing of our SDN controllers like VMware's NSX. Within these IaaS platform environments, we license them based on the number of virtual cores assigned to the gateway. So if we have in this example one gateway with which we assigned 2 virtual cores, another gateway we assigned 4 virtual cores, another that's assigned 1 virtual core, another that's assigned 6 virtual cores, and another that's assigned 2 virtual cores, we just need to purchase one license that covers 15 virtual cores. So remember, vSEC in these environments work in network mode, so they protect those infrastructure as a service environment. We can then connect that into the same single unified management, but in this instance, we license it based on the number of virtual cores we will assign to these vSEC gateways, versus how we do this with SDN controller, which is based on the number of physical CPUs. So now what we have is a unified management, and this is key for Checkpoint, in the fact that we can now manage all these various platforms within our software-defined data center that connects to a number of public clouds, whether this is AWS, Azure, vCloud Air. We can now provide a unified security management and threat visibility across our virtual, physical, and public cloud gateways. And of course, because we have integration within all these platforms, we have threat visibility inside the data center. And if you're leveraging Checkpoint Smart Event to monitor and investigate threats, we can now do that across our north, south, and east and westbound traffic, or the lateral traffic, the 80% traffic today that we're missing. In fact, Checkpoint today is a single vendor that's able to secure the modern data center with more automation and higher security between applications with a single unified management system. And effectively, this is the grand vision of vSEC, the one point or the one-stop shop to connect our VMware environments, our OpenStack environments, our New Age Networks environments, Cisco environments, Microsoft Azure environment, Amazon environment, into one single pane of glass. So I mentioned today that vSEC is much more than just the SDN controllers we've been talking about within the context of a software-defined data center. So let's look at what we support today and what we have on the roadmap. So today, we support vSEC for NSX. And this effectively provides microsegmentation for your data center to secure the east and west traffic between applications, the main theme of today's presentation. In the short future, we'll be supporting Cisco's ACI SDN controller in the same fashion. For the virtual data center, we support Virtual Edition, also known as VE, and shortly we'll be in the roadmap, we'll be supporting vSEC for OpenStack. When we look at public infrastructure as a service, so bear with me a moment. If we look at public infrastructure as a service environments, we can secure applications and connectivity into the public cloud. And today we support vSEC for Amazon Web Services and vSEC for Azure. Very shortly and on the roadmap, we will support vCloud Air. Now for us partners out there, it's important to note that what we support today, great, but what I've mentioned that is on the roadmap, if you have any POC requirements, we have the ability today to perform POCs, whether this is across Cisco ACI, OpenStack, or vCloud Air. Get in touch with your local SE and we will be able to support any POCs. So remember vSEC in a nutshell, although mostly we've been talking about vSEC in the context of a software-defined data center, now we are aware that it can expand into public infrastructure as a service as well as other components. But the core themes of a vSEC gateway is its A, application-aware policy, so the security policy with applications identity tied to the SDN and cloud platforms. So effectively, when we tie it all into all these multitudes of platforms, we can have a unified policy that looks effectively what we see in front of us. So in this example, in Rule 3, we have the Finance app from vCenter going to the database group, which is a security group within NSX, with a particular application and permit or deny action. In the middle rule, we have an object from OpenStack going to an object within Cisco's ACI, and again, an action with what's allowed and what isn't allowed. And in the final rule, we have a user ID, so this is from Identity Awareness, going to an object within Amazon Web Services, using SAP application, and it is allowed. So you can start to see, I mean, let's not drill too much on the rules themselves, but what you can start to see is this unified policy coming together to bring about all these environments that we're leveraging in a software-defined data center into this single unified policy with all the benefits that we've seen and discussed up to this point, such as automation and orchestrations and so on. And of course, the shared policy tagging. So this is a very unique feature to Checkpoint when we look at, compared to other players that service this particular niche. We're the only one today that can detect a virtual machine to see if it's infected and then send that tag to the relevant SDN controller in order for the SDN controller to automatically quarantine and trigger remediation. And of course, when we bring about our next next generation security management platform, for those in the know, R80, we can start to leverage sub-policies within our micro-segmented environment. So with R80, we can take that micro-segmentation and assign its own sub-policy layer to each of those micro-segmented environments. And with each of those sub-layer policies, we can assign our own admin or teams of admin. In fact, R80 brings about a host of functions and features that's going to revolutionize the way we administrate our security policy. It was designed from the grounds up to accommodate the way we start to do security and the way we're going to do security in the future. And on that note, it's probably a good opportunity to remind people in the audience today that next week, my colleague Don Patterson will be delivering a presentation on R80's next generation security management system. So definitely tune into that at 10 o'clock or same time next week. Okay, so in summary, We've talked about vSEC, the advanced security for the hybrid cloud. We've primarily been talking about the private cloud or the software-defined data center, but we've now opened that up into the public cloud realm to see how that all comes about together to provide a nice security solution. We talked about the security automation, being able to import all of those objects that live in different ecosystems, such as NSX, Cisco, ACI, OpenStack, and so forth, and be able to bring those objects into our checkpoint policy manager, and also to have those objects updated anytime there's a change within its respective ecosystems. And then, of course, the main compelling point is the unified security control and visibility. We effectively have the visibility and the ability to leverage control from a single pane of glass across all of these platforms. We don't need to put in disparate point products, different management systems. We can leverage our existing investment that we have today with Checkpoint and just introduce the functionalities required and the licensing required to encapsulate those controls. Security that takes your modern data center one step ahead. And on that note, I'd like to thank you for tuning in. I hope this webinar has been informative for you. I'd like to wish you a good afternoon and a good weekend. Thank you very much.